Quantum computing breakthroughs, top players to watch in 2024. In the world of technology, quantum computing has often felt like a distant dream, an enigmatic field where physics meets computer science, promising to revolutionize everything from cryptography to drug discovery. For years, it's been the buzzword of tech conferences and deep-pocketed labs, but practical, large-scale quantum computers seemed perpetually out of reach. That narrative might be shifting in 2024. A perfect storm of new government funding, remarkable experimental milestones, and ambitious startups racing alongside tech giants has reignited what many are calling the quantum hype cycle. But beneath the buzz in the headlines, there's a complex, nuanced race unfolding, a race to commercialize quantum computing technology before anyone else can. Today, we're diving into the top players driving this quantum leap and what it means for the future of computing. Why now? The quantum renaissance. First, why is 2024 suddenly such a pivotal year for quantum computing? The answer lies in a confluence of factors. Governments worldwide have recognized quantum technology as a strategic priority. The US, European Union, China, and others have poured billions into research grants and infrastructure initiatives aimed at accelerating quantum breakthroughs. For example, the US National Quantum Initiative recently boosted its funding by over $1 billion, explicitly targeting scalable quantum hardware and practical applications. Europe's quantum flagship program is now in its second phase, doubling down on collaborative research across academia and industry. China has expanded its quantum research centers, particularly focusing on quantum communication and encryption. At the same time, experimental milestones have moved beyond incremental improvements. In late 2023, Google's quantum AI division demonstrated a quantum processor that maintained coherence times and gate fidelities long enough to perform error-corrected operations, a critical stepping stone toward fault-tolerant quantum computing. IBM unveiled a 433-qubit machine, one of the largest yet, and promised a 1,121-qubit system within the next 2 years. These developments have reignited investor and public interest. The quantum hype cycle is back, but this time with tangible progress to back it up. Startups, the quantum wildcards. While the tech giants are making headlines, startups have become the wildcards in this race. They often operate with more agility and risk tolerance, essential in a field where the path to commercialization is strewn with technical hurdles. One startup to watch is PsiQuantum, a Silicon Valley company pursuing photonic quantum computing. Unlike superconducting qubits used by Google and IBM, PsiQuantum's approach leverages photons traveling through optical circuits, potentially enabling room-temperature quantum computers that are easier to scale. They recently announced a $450 million funding round, the largest private investment in quantum computing to date, signaling strong investor belief in their approach. Another notable contender is Quantinuum, a company spun out from Honeywell Quantum Solutions. Quantinuum combines hardware and software capabilities, offering cloud-accessible quantum computing services to enterprise clients. Their recent breakthroughs in quantum error correction have improved system stability, pushing practical quantum advantage closer to reality. Then there's Rigetti Computing, an early pioneer that's pivoted towards hybrid quantum classical computing models. By integrating classical processors with their 80-plus qubit machines, they aim to tackle specific optimization problems for industries like finance and logistics, where even modest quantum improvements could translate into substantial cost savings. Tech giants betting big on quantum. On the other side of the ring, tech giants are doubling down on their quantum ambitions, leveraging deep pockets and vast infrastructure to accelerate development. IBM has been a quantum computing trailblazer for years, pioneering the cloud access model with its IBM Quantum Experience platform. Their roadmap is aggressive. They plan to scale from 433 qubits now to over 1,000 qubits by